JMath.
In this video, we'll be looking at general solution, but the advanced type of general solution sums, where things don't work quite as it does with the easy ones. So how do I recognize this? In the previous video, we had sums where sine theta was on the one side and cos theta was on the other side, and you could just divide to make it tan theta. But in this video, the sums will have sine on the one side, cos on the other side, but the angles will not be the same. Both will not be theta. So in that case, you will have to use co-functions, and then we are going to do a few other steps as well to get to the answer. So let me start with an easy example, and then I'll run through the steps. But you're welcome to pause the video here, copy down these steps, and then we will apply it to every sum. Question 1. If sine 3x is equal to sine 75, and x is an element of minus 360 to 360, solve for x. Okay, now the big difference with these sums are that you will still get the quadrants, but your reference angle is actually given to you. So you don't need to shift sine or shift cos with these. So what I mean with that is I can see both sides are positive, so I know we're going to work in quadrant 1 and 2 because it is sine. But in this case, the reference angle I'm working with is the angle or the bracket or the expression that is on the right-hand side. So in this case, 75 degrees. Okay, so in quadrant 1, I'm now going to write down the left-hand side expression or number or whatever they give me. That's what I'm going to start with. And the reference angle is going to be the right-hand side. So I'm then going to write 3x is equal to, it's quadrant 1, so I can just write reference angle plus k 360. And remember, k is an element of z. And now I just need to divide by 3 on both sides. This is 25 and this is 120. But it's sine, so I can't just say, oh, it's just 75. It must also be equal to 180 minus 75 because it's the second quadrant. So 3x is also equal to 180 minus reference angle plus k 360. So in this case, x would be equal to, that is 105 divided by 3. So my final answer would then be 35 plus k 120. So I would normally just stop there if they asked me for the general solution, but in this case, they asked me for the specific solution. So now I need to find all the values that satisfy those two equations that lie between minus 360 and 360. So just like in the previous video, I'm going to use the table method on my calculator to get these answers. So the 25 plus 120, I'm going to put in fx, and then the 35 plus k 120, I'm going to put into gx. Start. Now, this is now where it gets tricky because I have a very big window, minus 360 to 360, and my k values are quite small. So I'm actually going to have to start at minus 4 and end at plus 4, just to make sure that I'm covering everything and I'm not missing something. So according to my calculator, those are all the answers. Just make sure you have all of them. In exams, they will normally not make you write 12 separate answers, but in this case, this is what they wanted. Example 2, cos 2x is equal to minus cos, and then in bracket x plus 30. So I have cos on both sides, and this is one of those where I'm not going to use shift cos to get an answer. So I'm going to start with the left-hand side in my quadrants, and the right-hand side bracket, the x plus 30, is going to be my reference angle. Firstly, which quadrants am I working with? If cos is negative, quadrant 2 and quadrant 3, my reference angle is going to be x plus 30. So now in quadrant 2, I can say 2x is equal to 180 minus bracket x plus 30, and then plus k 360, and I know k is an element of z. So now I can just simplify a bit. So 2x is equal to 180 minus 30 gives me 150 minus x plus k 360. So I'm taking the x's to the one side, and then is equal to 150 plus k 360, and then I want x alone. So the answer to this question is 50 plus k 120, but that was only quadrant 2. So now for quadrant 3, I'm going to do exactly the same, but it's going to be 180 plus. So 2x is equal to 180 plus x plus 30. So technically I have to put that in a bracket, but because there's a plus in front, it does not matter. Plus k 360. So I can see I'm going to take the x to the other side. So I'm just going to skip a step and say this is x equals 210 plus k 360. So in many cases, this is actually an easier question than the other one where you work with decimals and all of that. But these are the steps you need to follow, and that would be my final answer. They did not ask me for specific solution in this case, so I can just stop there. Example 3, cos 5 theta is equal to cos theta cos 40 plus sine theta sine 40. Now, normally, you do not have to use your identities like compounds and doubles and things, but in this case, it would be really tricky if I don't use a compound identity. So I'm going to make it easier for myself, and I'm going to say, okay, so cos 5 theta is equal to, and now I need to see, okay, it's cos, and there's a plus in the middle. So this I can write as cos theta minus 40, so a minus b, if I look at the identities. And now I can just follow the steps the same as the example to the left. So my quadrants, cos is positive, so it's quadrant 1 and quadrant 4. reference angle is the right-hand bracket, so theta minus 40 is my reference angle. In quadrant 1, it is 5 theta equal to just reference angle, so theta minus 40 plus k 360. I can take this over and this becomes 4 theta is equal to minus 40 plus k 360, and then divide by 4, so theta is equal to minus 10 plus k 90. That's the answer for quadrant 1. And then quadrant 4, the answer would be 5 theta equals to 360 minus reference angle, minus 40, and then plus k 360. Now I can just see this is going to be a minus theta, so I'm going to bring it to the left. This is then 6 theta is equal to 400 plus k 360. So to get the final answer, I just need to say 400 over 6. That gives me 66.67 plus k of 60 degrees. So if I look at this, I'm not done because I forgot to write k is an element of z. So really, guys, you can just put that anywhere next to the sum. As long as it is there once in every sum, you will not lose marks. Example 4. So now it can get tricky for many people. So in a previous video, when we had sine on the one side and cos on the other side, we divided by cos so that it becomes tan. But now the brackets are completely different, and I won't be able to get tan if it's not the same bracket. So in this case, I'm going to use cofunctions. Now you can make both sides sine, or you can make both sides cos. It really doesn't matter. It's going to get to the same answer. So I'm just in this case going to stick with sine and say sine 15 plus x would be equal to sine, and then I'm going to do a block bracket, 90 minus x plus 30, close round bracket, close block bracket. I'm just going to simplify a little bit to say sine 15 plus x is then equal to, this is a 90 minus 30, if I multiply that minus in, so this just becomes sine of 60 minus x. Now I can say it's sine, both are positive, so it is quadrant 1 and quadrant 2. Reference angle is the right-hand bracket, so 60 minus x. So for quadrant 1, 15 plus x is just equal to reference angle, so 60 minus x plus k 360, and k is an element of z. So take the x's to the left, I have 2x is equal to 45 plus k 360, and therefore x is just equal to 22.5 plus k 180. I also need to do quadrant 2 because sine was positive in both, and therefore 15 plus x is equal to 180 minus reference angle, which is 60 minus x, and then plus k 360. So now if I simplify, 15 plus x is equal to 120 plus x plus k 360. I bring all the x's to the left, and then I see I'm going to hit a problem. So this is just 105 plus k 360. But on the left, my x's cancel out. And I know that 0x cannot equal 105. So therefore, no solution. So if that happens and you lose your x, it's fine. Just write no solution. And then in this case, only quadrant 1 exists where those two expressions that I have equal to each other at the very start, they only intersect in quadrant 1. And that's why the answer for quadrant 2 does not exist. Last example for this video, for which values of x will cos of minus 60 plus x equal minus sine 3x? Once again, I can decide if I want to work with sine or with cos. Let's just stick with cos in this one because we did sine with the other one, just to show you that it will work out either way. So minus 60 plus x, and then this one, I'm just going to do minus cos 90 minus 3x. I can see that there's a minus in front of the right-hand side. So then I'm going to say my quadrants is where cos is negative. So I know that is in quadrant 2 and quadrant 3. Reference angle in this case is just 90 minus 3x. So please don't let that extra minus throw you off. I only use it to identify the quadrants. After that, I ignore it completely. So my reference angle is still only the bracket on the right. So to get the solutions for this sum, I can say in quadrant 2, minus 60 plus x is equal to 180 minus, and then brackets 90 minus 3x plus k 360. And I just need to put this somewhere on my page. K is an element of z. Okay, so now I want all the x's on the left, but this thing looks horrible. So I'm just going to simplify one step further. Is equal to, and this is then 90 plus 3x plus k 360. If I bring all the x's to the left, this is going to be minus 2x. This is going to be 150, and that's then plus k 360. When I divide, it's really fine if you get a negative. So minus 75, perfect. Now, the plus k 360, I know it's going to be k 180, and technically, if I do algebra, it must be a minus. But because it's an extra thing that I just add to the sum, it doesn't matter if it's a plus or a minus there. It's actually more accurate if you leave it as a plus. But just to stick with algebra rules, I'm going to write a minus there. But remember, your teacher might say, no, that is always a plus because it's something extra that I add to the sum. Okay, quadrant 3. So now I'm just going to start the very same. So minus 60 plus x is equal to 180, but in this case, plus reference angle. So once again, just going to simplify a little bit. So plus x, and that's then equal to 270 minus 3x plus k 360. That becomes 4x is equal to 330 plus k 360. And then I just divide everything by 4. And therefore x is equal to 82.5 plus k 90. Okay, guys, so it's still general solution, works a little bit differently than the normal ones you did last year and in the previous video. But these are the rules. Just follow them and they won't be able to catch you out.
If this video helped you, please like and subscribe.
JMath.